5.1c is on negative and zero exponents. So remember we've talked about the product of the power, where if we're multiplying two terms with the same base, we add the exponents. Quotient of a power, if we're dividing two terms with the same base, we subtract the exponents. And power to a power, anytime we have something raised to another power, we are multiplying those exponents. So here are our last two exponent rules. So before we look at our negative and our zero exponent rule, let's look at how they found it. So we looked at this a little bit in class, but essentially each time you're taking away an exponent, right? So from 2 to the 5th power down to 2 to the 4th power, we are subtracting 1 from our exponent as we're working our way down this chart. So essentially each time we get rid of an exponent, we are dividing by 2. In other words, multiplying by a half. Okay, so that's what's happening. So when we get down to like 2 to the 1st power, which is 2, well, if we multiply that by a half, we get 1. If we multiply that by a half, we get 1/2. If we multiply that by a half, we get 1/4. And so this is where the zero and the negative exponent rule come from. Right? If you have a number raised to some power, essentially you are dividing by that number or you are multiplying by its reciprocal. So here are the rules. Zero exponent rule, any x or any number raised to the 0 power is going to be equal to 1. For our negative exponent rule, essentially, if you have a negative exponent and you want to make it positive, put it on the other side of your fraction. So x to the negative nth power equals 1 over x to the n. Notice how our base stayed the same, our exponents stayed the same, but we put it on the denominator of our fraction instead of the numerator. Same if you have a negative exponent in your denominator, like the second example, right? 1 over x to the negative n. Well, we would put that in our numerator, right? So those are our two rules, so we are going to practice them. We want to simplify all of these completely. So A, we have k to the negative 4th. Well, we just talked about how we would put that in a fraction, right? So technically k is in the numerator right now. We could write this as k to the negative 4th over 1. So to make it positive, we would put this as 1 over k to the 4th. Notice how the base stayed the same, the exponent stayed the same. It's just we put it in our denominator and we got rid of that negative. 1 over y to the negative 6th, well, that's in our denominator, so we would put it in our numerator, and that would be our answer. Letter C, we have a to the 8th times b to the negative 3rd times c to the negative 6th. Well, a, b, and c, those are all different bases, so we can't combine any of them. A is already positive, so a to the 8th power is going to stay in our numerator, but b to the negative 3rd, well, that's going to go to our denominator to become positive, and c to the negative 6th, that's going to go to our denominator to become positive. So this would be our final answer. Let's practice a couple more. Looking at D, we have negative 5 times m to the negative 3rd times n to the 9th power. So looking at this, recall that a negative exponent is different than a negative coefficient. So negative 5, this is technically negative 5 to the 1st power. So it's got a positive exponent, which means it gets to stay in our numerator. So we're going to have negative 5. Okay, m to the negative 3rd, well, we'll put that in our denominator to make it positive. And n to the 9th is already positive, so our answer would be negative 5 times n to the 9th divided by m to the 3rd. Again, since this is negative 5 is a negative number, so it gets to stay. If we have a negative exponent, we need to make it positive. So just keep in mind that there's a difference between exponents and those coefficients. Looking at letter E, we have g times h to the negative 8th divided by k to the negative 5th times j to the negative 9th. But all of this is raised to the 0 power. So since all of this is raised to the 0 power, we could do our power to a power rule and distribute our 0 to each of these. But essentially what will happen, anything raised to the 0 power is just 1. So this will just be equal to 1. Now it'd be a good time to pause and see if you can figure these out for yourself. Letter F, we have f to the 5th times f to the negative 8th. Notice that these have the same base, so we actually have to combine something to simplify these completely. So we can do this a couple different ways. If you wanted to get rid of the negative exponents first, you could, or if you want to combine the exponents first. So whatever you want to do first is fine. You get to decide. I'm going to combine my exponents first. So I'm multiplying two things with the same base, which means I can take 5 plus a negative 8. Well, 5 plus a negative 8 would be f to the negative third, and then to make that positive, I would put it in my denominator. So f to the fifth times f to the negative 8th is equal to 1 over f to the third power, and that's my answer. Letter G, notice how I've got two separate things. I don't have any powers to share to them, so I'm just going to start by organizing my variables. I have a to the second times a to the sixth, and I have b to the negative third times b to the third. Well, again, I'm going to start by combining my exponents. So since I'm multiplying, I can take a to the 2 plus 6, and I can take b to the negative third plus positive 3. Well, 2 plus 6 would be a to the 8th. Negative 3 plus 3 would be b to the 0. Well, anything to the 0 power is 1, so this is just a to the 8th times 1, which is really just equal to a to the 8th power. So that would be our final answer. Again, if you haven't yet, pause, see if you can figure some out for yourself. Letter H, 3 raised to the 0 power, that would just simplify to 1. So basically we have a 1 in our numerator. We have t to the negative second times t to the negative fourth. Well, we could add those together, so negative 2 plus a negative 4. So we'd have 1 over t to the negative sixth. Well, we don't want any negative exponents in our answer, so we would have to bring that to the other side of our fraction, in other words, to our numerator, and we would just end up with t to the positive 6. Notice how when we flip it to the other side of our fraction, technically we're going from having 1 over t to the negative 6 to having t to the positive 6 over 1, but t to the 6 over 1 can just be written as t to the 6th power. Looking at letter I, we have a lot of stuff going on. So we have negative 2 times v to the second raised to the third power. So let's just start with our power to a power rule. We've got negative 2 to the first power, so we'd have negative 2 raised to the third power, and then v to the second raised to the third power, so we'd be multiplying those exponents. And then we've got 3 times v to the 0 power. Well, anything to the 0 power is just going to be 1, so that just simplifies out to 1. And then 4 times v to the negative 9th power. Well, negative 2 to the third power is saying we have negative 2 and we're multiplying it by itself 3 times. V to the 2 times 3 would be v to the 6th. Multiplying 1 doesn't really change anything, so we could just drop that, times 4 times v to the negative 9th. Well, let's put our like terms together. Negative 2 times negative 2 times negative 2, it would stay negative because there are 3 negatives, and then we'd have an 8 times this 4, and we'd have v to the 6th times v to the negative 9th. Well, negative 8 times negative 4 would be negative 32. Notice that it's a negative whole number, so it's fine. That negative gets to stay. V to the 6th times v to the negative 9th would be v to the negative third, but we have a negative exponent, and that we have to change. So our final answer would be negative 32 over v to the third power. Okay. Then we just have a couple more we're looking at. So J, we have a lot of stuff going on. We have like terms in our numerator and our denominator. So again, you can, a lot of different ways to solve this. You just have to decide what way you want to use. So I'm going to start by combining my exponents. Well, since this is our quotient rule, we'd be subtracting them. So I'd have m to the negative 4 minus 2, which would be negative 6. Then I'd have n to the negative 12 minus a negative 8, negative 12 minus a negative 8, which is really negative 12 plus 8, which would be negative 4. And then I'd have p to the 7th minus p to the 1st, which would be p to the 6th. Well, I've got two negative exponents that I need to switch, so I would have, this is all over 1, so m to the 6th would be in my denominator, n to the negative 4th would need to switch to my denominator, but p to the 6th gets to stay in my numerator. And that would be our final answer. Notice that we know it's our final answer because all of the exponents are positive and all of our like terms are combined. Letter K, well, we have 3 times t to the 0 power divided by t to the negative 4th power. T to the 0 power is just 1, so we really have 3 times 1 over t to the negative 4th power, which is just 3 over t to the negative 4th power, but we don't want that negative, so we have to bring that to our numerator, so it's really just 3 times t to the 4th power, not the 3rd power. the 4th power. And that's our answer. Last two. So we've got 3 over 4 raised to the negative 2nd power. Okay, well, a couple different ways we can do it, but I'm going to start by using my power to a power rule. This is 3 to the 1st power and 4 to the 1st power. So we really have 3 to the 1st times negative 2 over 4 to the 1st times negative 2, which would just be 3 to the negative 2 over 4 to the negative 2. Well, since they're negative, basically we have to flip them around in order to get our positive exponents. So we'd have 4 to the 2nd divided by 3 to the 2nd, which would be 16 divided by 9. Letter M. So letter L, that was one way to do that type of problem. Letter M, since it's a negative exponent and we have a fraction, we could just flip everything right away and turn it into a positive exponent, which means we would just have p to the negative 3rd over 4 times n to the 8th times n to the 4th. Notice that I flipped everything exactly, and then instead of being to the negative exponent, it'd be to the raised to the positive exponent. And we could do that if we wanted to. You could do it using the power to a power rule like we did in L, but if you wanted to just flip it around, you could do that also. And then from there, we'd use our power to a power rule. Well, p to the negative 3rd times 3 over 4 raised to the 3rd power times m to the 8 times 3 and n to the 4 times 3. Evaluate that, leaving us with p to the negative 9th over 4 to the 3rd times m to the 24th and n to the 12th. Well, we can't have that negative exponent in our numerator, so we'd have 1 over 4 to the 3rd times m to the 24th times n to the 12th times p to the 9th, and that would be our answer. You could also evaluate 4 to the 3rd to write it as 64. Then, looking at our negative exponent rule, remember basically you just flip it, you move it to the other side of your fraction, and the 0 exponent rule, anything raised to the 0 power, is just going to equal